Okay, in this video we're going to talk about how mirrors create images. It's going to be a lot like lenses, so if you understood lenses you should be in pretty good shape for mirrors. So first off, this is a concave mirror because the light is going into it like it's going into a cave. And it's a converging mirror because the rays that come in parallel converge at a focus. So these guys are coming in, it hits the mirror and reflects, and it's going to reflect down through that focus. It has a positive focal length. A convex mirror is a diverging mirror because parallel light, parallel rays reflect away from a focus. So this ray right here is coming in, it hits the mirror and bounces off, going directly away from this focus. And we say that these have, when we're doing our math, a negative focus. So there's something I want you to be aware of. Okay, if I talk about converging, we just said that that works for a concave mirror, like this. But it was true for a convex lens. So you have to kind of memorize that, okay? A converging mirror is a concave mirror, and a converging lens is a convex lens. So concave mirrors are actually going to act like convex lenses. And then for diverging, that is for a convex mirror, meaning going out towards the light ray, or a concave lens. Like that. So convex mirrors act like concave lenses. And one thing we learned, okay, is that for a diverging lens, they always make small and right side up images. That's going to be true for a convex mirror as well. So, on to our examples. I'm going to change this to a 2 centimeter tall object because it won't work very well with a 3 centimeter tall object because there's something called spherical aberration, which we're going to talk about in the next video. So what I want you to do is change the height of that object to 2 instead of 3. Now, we draw in, we have to locate the focus and the center for this. It says there's a radius of curvature of 4 centimeters. At the end of a radius is the center. So they're telling me to place the center at 4. So 1, 2, 3, 4 away from the mirror is where I put my center. Okay? And then remember that the focus is always at the center divided by 2. So if the center is 4, the focus is going to be at 2. So that's something we have to remember too, is that the focus is halfway to the center. Now, I draw in the same rays that I drew for lenses. The ray that goes parallel is going to hit the mirror and then it is going to bounce down through the focus. So parallel goes through the focus. The second ray we drew always went straight through the center. So they go from the top of the image straight through the center. And where they meet is where I draw my image. So they're meeting here. So I draw from the axis down to the meeting point, and that is where my image is. Now, for my and we're going to say that this is a small, inverted, and real image. Now for the math, 1 over dO plus 1 over di is 1 over f. 1 over 6 plus 1 over di equals 1 over 2. We'll do the math quickly. It's the same math we did for the lenses. So if I solve this, I'll get 1 over di is a half minus a 6, gives me 2 6. So di is 6 over 2, or 3. And you'll notice that it's about, if I go from the mirror, 1, 2, 3 away. It didn't come out exactly the same because when I drew this curve for the mirror, I didn't use a protractor to do it, so it may not come out exactly right, but it should be close to matching. And SI over SO equals DI over DO. SI over 2 this time equals DI, we just calculated, was 3, DO was 6, so SI should end up being 1. And if we look, the height of that image is about 1 square. Top of the next page. All right, again, I'm going to change this to a 2 centimeter tall object. They're giving me the focal length this time of 4. All right, so that's different. Okay, so I have to place my focus at 4. 1, 2, 3, 4. There's my focus. Remember, the focus is the center divided by 2. So the center is twice as big as the focus, so it has to be at 8. 5, 6, 7, 8. So there is my center. And like I said, we're going to make this a 2 centimeter tall object again, because 3 centimeter tall won't work. Now, we draw in the same rays. We go from the top of the object parallel. So it hits the surface, down through the focus. The second ray we draw goes straight through the center. So from the top of the object, straight through the center. Okay. Those are never going to meet, so I have to extend them back behind the mirror until they do meet. So I'm going to do dotted lines. When I extend them, I use dotted lines going back along the rays until I find where they meet. So it looks like these are going to meet somewhere around there. Then I'm going to draw in my image from the central axis to the point where they meet. So this is an arrow pointing upward. Okay, so now we have a big upright and virtual image. So for the math, 1 over DO plus 1 over DI equals F. DO was 1, 2, 3. 1 over 3 plus 1 over DI equals 1 over, focus for this was 1, 2, 3, 4. So 1 over DI is 1/4 minus 1/3. Denominator is 12, so it's 3/12 minus 4/12 is 1/12, negative 1/12. So my DI is negative 12. Now what that means, okay, is that it is behind the mirror and that it is virtual. Now again, it didn't work out exactly right. It should be 12 away from the mirror, and it's more like 1, 2, 3, 4, 5. But it does show it's behind there. Then for the math, SI over SO equals DI over DO. So SI over 2 equals DI, we just found out, was negative 12 over 3. And that's going to give me SI equals 8 centimeters. Negative 8 meaning it's upward, and the height of it's 8. And it's not exactly 8 in our diagram, but it is much bigger than the object. The last one. Okay. A 3 centimeter tall object again. Let's make it 2 centimeters. So we're going to make it this tall. Okay, it is 8 centimeters from a convex mirror this time. Okay, it's convex because it's bowed out toward the object with a focal length of 3. And remember, this is the convex is diverging. So F is negative. So F is negative 3. Now, the focus is going to go on the other side of the mirror this time, because the center, if you think of the mirror as being part of a circle, the center of that circle is going to be over to the right of the mirror, and so is the focus. So we're going to put the focus at 1, 2, 3 right here, and then the center is always twice the focus, so that'll be at 6 right here. Now we'll do our ray diagram. We always start with a parallel ray. We draw the parallel ray until it hits the surface. That one this time, since it's diverging, instead of bouncing down toward the focus, it's going to go away from the focus. So I'm going to do a dotted line until I get to the surface, and then a solid line going away from there, like so. So the light travels to the right, parallel hits and bounced away from on the mirror, bounced away from the focus. Our second one we draw always goes through the center. Okay? And so the light starts at the top of the object, goes towards the center. Now it can't get behind the mirror, so for the part behind the mirror, I draw it dotted. So something like that. And where they meet is where we place the image. So they're meeting way back here. So I'll draw my little arrow pointing upward, away from the axis, and there's my image. So the image is small, upright, and virtual. And just like for diverging mirrors, I always got small, upright, and virtual. Sorry, diverging lenses, I always got small, upright, and virtual. For diverging mirrors, I will always get small, upright, and virtual. For the math, 1 over DO plus 1 over DI equals 1 over F. 1 over 8 plus 1 over DI equals 1 over, and remember it's -3 for the focus because the focus is on the back side of the mirror for a diverging lens. So 1 over DI equals -1/3 minus 1/8. Common denominator would be 24. So this is going to be 8 over 24, -8 over 24, minus 3 over 24, -11 over 24. So DI is going to be 24 over 11 negative. I'm going to turn that into a decimal, and I'll get -2.18 centimeters. And if I look, we're always measuring from the object, from the mirror. So from the mirror, okay, here's the mirror, it's 1, 2, a little bit more than 2 away. So -2.18 makes sense. And SI over SO equals DI over DO. SI is what I'm looking for. Our SO was 2 equals, I'm going to put this in fraction form to make life easier, -24 over 11 over DO was 8. And if I do my math right, I'm going to get SI equals -6/11, which is just a little bit bigger than a half. And if I look at my diagram, okay, the height of that object does seem to be about a half, so it looks like it works.